so we have an A-level question, first principles with trick. Possibly a little bit horrible looking. A lot of people aren't going to be comfortable with this, and some of the manipulation you have to do isn't too nice. So I've already written the first principle formula up here, and I'm just going to explain what this is saying. So it's the differential of cos theta is minus sine theta, which means the function is cos theta, and the function of x plus h is cos theta plus h. Now, I've already underlined the compound angle formula here. They've told us to assume the formula, and this is clearly a compound angle. So we are just going to apply the rule for this into here, which leaves us with cos theta cos h minus sine theta sine h. And there's not much more we can do right now with expanding or manipulating, so we're just going to put it into the formula. So the differential, well, we should be using theta here because it's in terms of theta, would be cos theta cos h minus sine theta sine h over h. I'm ignoring the limits for a moment because we'll apply them at the end. So, is this any help? Not really. Can we manipulate anything? Not really. I was a bit silly and I did forget to write the minus bit here. So, based off just this, there's not a lot you can do. Maybe we can factorize, maybe we don't factorize, but once again, they've helped us out so much in this question because if they're giving you specific things in the question, you should use it. So how are we going to get sine h over h? Well, right now we've got one long fraction, let's split it into two fractions. Let's split it into cos and sine. So we have cos theta, and I'm going to just factorize to make life a bit easier. And then we've got cos h minus 1 over h minus sine theta sine h over h. So, again, we can manipulate this however we want, and the best way to write it would be to have this part stand alone. So if we write cos theta times cos h minus 1 over h minus, and then here we've got sine h alone, so sine theta times sine h over h. When we